So, as with other problems in this particular data set, or problem set, we are looking to find the areas that are stuck between these two curves. Now, what are the initial clues that will allow us to set this integral up correctly? Well, one of the things I'm going to notice here is that this is a y squared, it's a single x. This is a parabola, but it's not your standard up or down parabola. It's one of those left to right. So no, if it's a left to right, I want to rewrite this parabola, but I want to do so as in the form of x equals a function of y. I'm going to solve this. I'm going to solve this for x. So I'm going to bring the x stuff over there. I'm going to bring the 4 over there, and I get y squared minus 4 is equal to 4x, or x is equal to 1/4 y squared minus 1. Everyone okay with that so far? Now, getting it in this form, now we know what direction this parabola opens. To the right. When it's positive, it opens up, because that's the positive y direction. When we're in the form y equals something x squared, when it's positive, it's a y, it opens to the right, where x gets bigger. Now, what else do we know about this parabola that opens to the right? How about when y is 0, x is negative 1. And that's as low as it goes. All right? So far, so good. What about the other thing? 4x minus y is equal to 16. What kind of curve is that?
Straight line.
It's a straight line, as compared to those other kinds of lines.
Diagonal line. With a positive slope.
Well, how about I do a quick, if I do the standard rewrite of this, I get 4x minus 16 is equal to y.
Don't you want to solve for y though? I mean x?
Or I can solve for x, in which case I get 4x is equal to y plus 16, which leads to x is equal to 1/4 y plus 4. Now, the reason I wrote it the first way, holy moly, I'm all mixed up here. The reason I wrote it the first way, because I find it's still easiest for me to graph these things when they're the standard slope-intercept form. This has a vertical intercept of negative 16. It has a positive slope of 4. So I think about that line, I'm like, I'm way down here, and I got a really steep slope, and I got something like that going on. Something like that. But I know that since I got so much of this x equals action going on, that I'm probably going to need that second way to actually write my integral. Now, where are my typical rectangles? Are they running up and down? Are they tall and thin? Or are they wide and squat?
Wide and squat.
Wide and squat. So I'm going to say a typical rectangle running that way, because no matter where I place that typical rectangle, I'm going from curve 1 to curve 2. All right? I'm going to remind you that the height of that typical rectangle is being measured vertically, so it's going to be specified by the differential dy, which means my area integral is going to have a dy in the end, and everything I write needs to be y's. Everything I'm writing is being referenced from the form of x equals to some function of y. Top curve, bottom curve. Red top or red bottom?
Red top.
Red top. Further to the right means higher x values. My line is going to be my top curve. And then I'm going to subtract off the bottom curve, which is the blue curve. Oh, it's not negative, is it? It's 1/4 y squared minus 1 dy. Almost done now. What's missing?
Our limit.
limits of integration. What is the lowest y and what is the highest y for that region? And what?
The intersects.
Well, let's find out where they intersect. Let's find out where does 1/4 y squared minus 1 equal to 1/4 y plus 4. I hate fractions. What?
Multiply all by 4.
Multiply everything by 4. I get y squared minus 4 is equal to y plus 16. If I subtract y from both sides, if I add subtract 16 from both sides, I've got that quadratic. 4 and 5.
Negative 5,
Negative 5, +4, which means y equals +5 and y equal -4. Does this look to be about -4?
Yeah.
Does this look to be about +5? Yeah, sure. So the lowest y value is -4, the highest y value is +5, and now we've got our integration set up, and now we can finish the job. All right. Let's see if we can do, is there any cleanups that we can do here? -4, -5. I can put the 4 and the 1 together, so let's distribute the -1 through. And I get a 4 and a 1, I get a 5 there. And how about a +1/4 y and a -1/4 y squared? So that's a little bit more organized. Now I think I'm ready to take the antiderivative. The antiderivative of 5 is 5y. The antiderivative of 1/4 y, 1/8 y squared. And the antiderivative of -1/4 y squared is going to be 1/12 y cubed, evaluated from -4 to 5. Any algebra mistakes yet? Because I feel one coming on.
Really?
I don't know. Today's been such a weird day. I was trying to do some of your problems, and I'm like, the numbers are just kind of swimming. I think it's too much caffeine.
That's how it was.
Well, no, I mean, I drank some extra Dunkin' Donuts coffees every day for the last 3 days. And I swear this morning I woke up and I had a little bit of a caffeine withdrawal headache.
If you look at the back of my
So
MMA
did you
packet,
drink
there's a
caffeine
giant
today?
doodle that I spent 30 minutes on.
I do not wish to know this. All right, let's evaluate this on these limits of integration. 5 times 5 is 25. 5 squared over 8 is 25 over 8. 5 cubed is 125 over 12. Minus, let's do the same thing again. 5 times -4 is -20. This next one is going to be a positive 16 over 8. And this is going to be 4 cubed. Wait, this is -1/12, and -4 cubed is -64, I believe. So, double negatives there. Then distribute this negative through. And what do we end up with when everything's done? A mess. 25 plus 25 over 8 minus 125 over 12. Plus 20 minus 2 minus 64 over 12. That should simplify. 25 plus 20 is 45. Minus 2 is 43. 125 and a 64 189.
Yeah, it is.
9. What?
Minus 189.
I was about to say 25.8.
Minus 189 over 12
Which is 30 and 3 eighths.
plus
30 and, oh, I mean,
25 eighths. What's our common denominator between 12 and 8? 24. So it's going to be 43. I'm going to multiply this by 2 to get negative 388. 78.
Does that divide by
24ths.
24?
And then I'm going to multiply that by 3 to get 75 24ths.
what are you doing? Why can't we skip the answer?
So that's 43 minus 303 24ths.
It's like 6.
Does it go in even? Does it go?
It's like
No.
It's 30.
It's divisible by
Yeah,
3.
30.375.
Well, both of these are divisible by 3. This is
12.65.
minus 101 over 8.
30.375. Why can't we?
Multiply both of these by 8.
That's
So
like
we get
12.6.
300.
243/8.
What's that?
It's total of 243/8 if you want the improper fraction.
243 eighths.
That's 30 and 3/8.
Why couldn't we have done that?
30 and 3
So
eighths.
much work.
But College Board doesn't like that.
Really?
They don't like mixed fractions. They would prefer 243 eighths.
That's crazy.
Well, the answer packet likes.
I saw that. I saw that in the answer packet. I'm like, no.
What about 30.375?
30.375 would be acceptable.
The 30.3 wouldn't be if it was.
30.3, no. Well, our rule is 3 decimal places if you're not exact. But that actually, 30.375 would be an exact answer. All right, so there's number 23. That was fun.